In this first video on ellipses, I'm going to go over some of the properties of ellipses that are important, and then in the second video we'll do some sample problems. Oops. Okay. So an ellipse is simply an oval, and we define it geometrically as a set of all points in a plane who have the same total distance between two foci, and foci is the plural of focus. So we have a focus here and a focus here. And if we pick any point, x, y, in the plane, we see that the distance d1, which is here, plus d2, okay, the distance to the second focus, that value is going to be the same anywhere I go. So if I go, say, over here, while the two distances changes, right, this distance is now going to be the new d1, but this shorter distance is going to be the new d2. Anywhere I go on this oval, okay, d1 plus d2 is constant. Okay? And the set of all points where those distances are equal creates this ellipse or oval. So just some definition of terminology. The line through the foci, okay, remember the foci are those points inside the ellipse, and if we draw a straight line through them, and this red line, the place where it intercepts the actual ellipse, here and here, those are each known as a vertex, or the plural of vertex is vertices. Okay, so those are the vertices of our ellipse. The chord, okay, so this red line segment that goes from one vertex to the other is known as the major axis, and the midpoint of that major axis is the center of the ellipse. Okay. The other chord that goes vertically, it's perpendicular to our major axis, this blue chord, which goes it's perpendicular to the major axis, goes through the center. That is our minor axis. Okay, and the major axis will always be longer than the minor axis. It is possible to have an ellipse that is that way. Okay, in this case, this would be your major axis, and this would be your minor axis. Okay. So this is something you want to copy down and have available to you, because this is what is kind of the key to solving all of these ellipse problems. We're going to define, now this, if you think about this as an ellipse on a coordinate plane, and it doesn't have to be, in this case I drew it centered at the origin, but it doesn't have to be, right? This is our y, and this is our x axis. We define the center of the ellipse as the point HK, and that's common to what we've done before. We did it with circles, we've used H and K with parabolas. So H would be your x coordinate of the center, and K would be your y coordinate of the center. Okay, in this case, H and K are both 0, but it does not have to be that. Okay, then we define this distance A. A is, if you think about it, it's going from the center of your ellipse all the way out to that vertex. Okay, so it's this distance here. Okay. And that distance we define as A, so that we could say our vertices, this particular vertex right over here is going to be our H value, the X value at the center, plus A, whatever that distance is. This one is going to be the H value of the center minus A. Okay? So our vertices are H plus or minus A, and the Y coordinate of the vertex, of each vertex, is whatever the Y coordinate of the center is, the K value. Okay? Now the foci, let's clear some of this out a little bit. Okay, so our axes are still in place. Remember, the foci are these points that are inside the ellipse. Okay, we define a distance c as the distance between the center and the foci. Okay, so the two foci, this one is going to be, again, the h coordinate is the x value of the center, so x plus c gets us over to the x value of this focus, and x, or h minus c, gets us over to this one. So h plus or minus c is the x coordinate of each focus. K, again, is the y value. Okay, we've already discussed this. The center is the midpoint of the segment joining the foci. So if I take this focus to this focus, this distance here, the center is, of course, the midpoint of that segment. It's also the midpoint of the segment joining the vertices, right? Remember, the vertices are here. And if I draw the major axis, or the segment that connects those, the center again is the midpoint of this is again the center of the ellipse. Okay. One final thing, we could use the Pythagorean theorem to get some lengths of these triangles, but in this case, C is not the hypotenuse of this triangle, so things come a little bit differently. If I wanted to solve for C, I can go through all of this, and this is the important thing you need to know. C squared is equal to, just solving this equation, a squared minus b squared. We're used to seeing c squared equals a squared plus b squared, so just be careful. This is a little bit different when we're dealing with ellipses, the way that we have the values defined. Okay, but that'll allow you to get your c value when we're working on some problems. Okay. So that leads us to the standard equation of an ellipse. Okay. I really don't want you to worry about what's down here, because all this is plugging in 0 for h and k and solving, so it just makes it look like it's really a lot more to remember than you need to. We have two cases. We have the case where the major axis is horizontal, so in other words, our ellipse is laying on its side like that. Well, imagine that being an actual closed figure. And the major axis being vertical would be an ellipse that is standing on end. Okay. The only difference between them is this denominator. Okay. Now, a squared is always going to be less than b squared. A is greater than b. So a squared is always going to be greater than b squared. Okay, and that's how you could tell if you have something mixed up and you don't know which is A and which is B. The bigger number is going to be A. Okay, and that is defined here. H and K again are your coordinates of the vertex. Of the center of your ellipse. A is the distance between the center and the vertex, so this distance from the center all the way to the vertex, which is on the ellipse. And b squared is the minor axis, so b squared would be this distance. Okay. Okay, so this is, that's A and that's B, not squared. Okay, so these are the formulas that we need to use to work these ellipses. And we'll take up in the next video starting with some problems.